Okay, this is super easy. You using the quotient identity, cotangent is cosine over sine. Okay, after that, sine is cancelled, and stay cosine x equal cosine x. That's the answer. Okay, this is also easy because you using the Pythagorean identity que I know que 1 plus cotangent square x is equal cosecant square x. So you replace. However, cosecant square x times cosine x. So I know the reciprocal identity que es que cosecant is 1 over sine. No? In this case, cosecant square is 1 over sine square. Yeah, I know that cosine over sine is cotangent. And both are squared, therefore the answer is cotangent square x. Okay, this is super easy. It's about the cofunction. The cofunction of sine is cosine. And the complementary angle 12 degree is 78 degree. Therefore, sine 12 degree is equal to cosine 78 is the answer. Okay. In that question, I select the left hand side of the identity. Case sine x plus cosine x squared. And you expand using algebra. Square the first plus twice, multiplication both, sine cosine plus cosine squared. Now, the next step, you apply Pythagorean identity because sine squared plus cosine squared is 1. And you replace, it's only 1 plus 2 times sine x cosine x is exactly the same of the right hand side term. Well, in this example, the first thing you should do is apply reciprocal identity. There's a cosecant square is equal 1 over sine square. This is step 1. Step 2 is apply Pythagorean. Because I know that 1 minus cosine square is equal to sine square. And finally, algebra, sine square divided by itself is 1. That's it. Okay, this is a little bit more complicated. You take the left hand side. And now you apply the Pythagorean identity. So it's like cosine square x minus 1 is equal to cotangent square. You are replaced by cotangent square. On the other hand, cotangent square is equal to cosine square over sine square. You replace. It's a question rule. Now, your simplification, algebra. Your simplification at least one side. So one side in the top cancel out with one side in the bottom. Stay those then cosine square x over sine x. And this cosine square you can split in two parts. Because the cosine square is cosine times cosine, no? Because cosine over sine is cotangent. And stay cotangent x times the other cosine, que is exactly the same to the right hand side. Done. Okay, and this question is easy. You take the left hand side, just two factors, cosecant square plus 1 and cosecant square minus 1, and you multiply. You multiply using this special product. A plus b times a minus b is a squared minus b squared. In our specific example, a is cosecant. It's a cosecant square minus 1 because b is 1. Now finally, you apply the Pythagorean identity. que say que cosecant square minus 1 is cotangent square. Okay, in this you take the left hand side of the identity. Yeah, I know very well. Okay, secant square minus 1 is equal to tangent square. You replace. You using Pythagoras, of course, identity. And the second step, well, you have the equation because tangent square is equal to sine square over cosine square. You apply quotient. And the third step, you apply algebra. You use simplification 1 cosine in the top and 1 cosine in the bottom. Stay then sine square over cosine. And finally, you apply the reciprocal, in which you know the 1 over cosine is secant. Done. Okay, in the question 10, you take the left hand side one more time. And you notice que cosine square x is equal to 1 minus sine square x. And you replace, so we're using Pythagoras identity first. Now, you factorization 1 minus sine square like 1 plus sine times 1 minus sine. Okay, this is just algebra. Finally, another algebra, we use simplification 1 plus sine x at the top and the bottom. Stay 1 minus sine x is exactly the same the right hand side. Okay, on question 11, one more time you take the left hand side. Because we have more a long expression can allow me manipulate. Then you apply algebra and you factor out sine of x. Entonces paréntesis 1 plus cotangent square x. This is algebra, just algebra. Now using Pythagoras, I know that 1 plus cotangent square is equal to cosecant square. Using reciprocal, well, no. Yeah, using reciprocal. Reciprocal, you replace sine of x by 1 over, so reciprocal of x cosecant. And 1 cosecant is cancelled in the top and the bottom, and it stays only 1 cosecant. This looks like more complicated. One more time, you take the left hand side expression for the identity, and you apply in top and bottom reciprocal. So you replace secant for 1 over cosine. Okay, now after that you apply some algebra. You multiply top and bottom by cosine. And cosine, so we have then 1 plus cosine square x over 1 minus cosine square x. Finally, apply Pythagoras. 1 minus cosine square is sine square. Bam! Exactly the same with the right hand side. Done. Okay, this is a typical example in which sometimes you need to multiply top and bottom by the conjugate. So the original expression in the left hand side was sine squared over 1 minus cosine. And you multiply by 1 plus cosine, which is the conjugate of 1 minus cosine. In order to doesn't affect our answer, you multiply and divide. This is working like a smart one. Now multiplication is sine square x, paréntesis 1 plus cosine x over 1 minus cosine x. Pero aquí 1 minus cosine square x is sine square using Pythagoras. And sine square is cancel algebra. And you stay alive 1 plus cosine x using reciprocal is 1 plus 1 over secant. And you put in the common denominator, secant, just secant, sorry. This is secant x plus 1. It's exactly the same with the right hand side. Done. This is a little bit sophisticated. For example, you take the left hand side, que es secant to the 4th power, multiplication tangent to the 4th power. And you separate secant to the 4th power like a secant squared, secant squared. Okay. And secant square, I know very well using the Pythagorean identity, is 1 plus tangent square. Now, if you apply distributive property, using tangent, not secant square, using tangent to the 4th power. Tan 1 is tangent to the 4th power, and tangent to the 4th power, tangent to the 2nd power is tangent to the 6th power, and secant square stay outside the parentheses. Done. Wow, this is too long. Okay, you take now the original expression on the left hand side. Obviously, you apply odd even property. Cosecant and sine are odd functions. Therefore, this minus inside the parenthesis, the argument, go outside and change minus cosecant x plus, because double minus, plus sine x. Now you apply the reciprocal. We're going to replace cosecant by 1 over sine. Of course, take the negative sign. Now, algebra. You express it both in one common denominator, que is sine x, is negative 1 plus sine squared x. Now, another extra algebra in which you factorization negative 1. So see, we have 1 minus sine squared. So I put an elegant way to identification, that the next step would be Pythagoras, because 1 minus sine squared cosine squared. Actually, I have in that moment minus cosine squared over x. Well, you split, why not, this cosine squared into cosine, and finally apply the quotient, because cosine over sine is cotangent, and the answer is minus cosine x, sorry, tan cotangent x. Exactly the same like the right hand side. Done the proof. Well, and this is a little bit weird, because combine trigonometric functions and logarithmic function. You have to remember logarithmic function. So you have logarithm of sine plus logarithm of cosecant, sorry. Now you apply the reciprocal in order to convert everything using sine and cosine. So logarithm of sine plus logarithm of 1 over cosine, reciprocal. Finally, you apply the rule of the product and the logarithmic. When you have two logarithm, addition plus is multiplication. You condense it in only one logarithm of the multiplication sine times cosine. 1 over cosine, sorry, reciprocal. Finally, algebra. Put together. Now, finally, quotient. Entonces, sine over cosine es tangent. Entonces, logaritmo tangent is exactly the same of the right hand side. Done. Okay, in this case, we are using the sum of different formulas. Okay, go over here. Tangent alpha minus beta is equal to tangent alpha minus tangent beta divided by 1 plus tangent alpha multiplication tangent beta. In our specific example, a 15 degree, I can predict que 45 minus 30. So we're using the angle the remarkable angle que you know, the trigonometric function. Actually, entonces ahí separé, alpha es 45, beta es 30. Entonces, tangent 45 es 1. Tangent 30 is radical 3 over 3. Plug it in. In this case, well, if you want to eliminate the denominator, multiply top and bottom by 3, and stay 3 minus radical 3 over 3 plus radical 3. You can leave it like that. However, we can simplification more, so rationalization, but no, it's okay. This kind of problem is very interesting. Alright, using the information given below to find cosine alpha minus beta. And cosine alpha is 8 over 17, and alpha lie in the first quadrant. That's me. que all trigonometric function que we found in alpha is positive. Tangent beta equal 4/3, with beta is in the third quadrant. That means cosine and sine are negative. Okay, let's do it. Now we are doing two triangles. One triangle for the alpha and one triangle for the beta. And the information is given. For example, cosine is 8/17. Therefore, adjacent is 8. Hypotenuse 17. And using Pythagoras, you find the other leg is 15. Okay. I don't care the position for the triangle. You suppose when you are doing the triangle always you suppose in the positive direction, in the positive like a line in the first quadrant. After you adjust the sign according to the quadrant. In the beta triangle, we have the famous 3, 4, 5 triangle. Entonces now I know the formula. Cosine alpha minus beta is equal cosine alpha times cosine beta plus sine alpha times sine beta. Entonces, every trigonometric function que corresponde with the alpha is positive. Entonces, cosine is 8/17. Que es given. Sine no. Sine is 15/17. Also positive. And the beta part, cosine beta, is 3/5, pero negative. Because beta, remember, lie in the third quadrant. And sine beta is negative 4/5, so opposite over hypotenuse, negative. The rest is arithmetic, multiplication and subtraction. The idea of this question is convert trigonometric expression to algebraic expression using the identity, sophisticated identity for the trigonometric. Then I want to suppose first que tangent inverse u is equal to alpha and cosine inverse b is a beta. Remember, the answer of the trigonometric inverse function is angle. In other words, u is equal to tangent alpha and b is equal to cosine beta. This allows me do two triangles. One triangle for alpha and one triangle for the beta. And of course, using Pythagoras, you'd find the third side is missing, no? In this case is the hypotenuse in alpha and the legs opposite in the beta. Okay, entonces using the formula for decomposition, cosine alpha plus beta is cosine alpha times cosine beta minus sine alpha times sine beta. Use substitution in any expression. Cosine alpha is 1 over square root x squared plus 1 times cosine beta is b minus sine alpha is u. U no is u over square root u squared plus 1, so opposite over hypotenuse, time sine beta is square root 1 minus b squared over 1, okay, is nothing. The rest is just algebra and that's it.